Hey everyone, welcome back to Backend Explained. In today's video, we are going to talk about one of the most important concepts in backend development API. You use Google Maps inside Swiggy. You pay using Razorpay inside some random app. You log in with your Google account on a third-party website. Have you ever wondered how that works? How does one app talk to another app? The answer is API. And by the end of this video, you will completely understand what an API is, how it works, and why every backend developer must know this. Let me give you a simple analogy first. Imagine you are sitting in a restaurant. You want food. The chef is in the kitchen. But you cannot walk into the kitchen and cook yourself, right? So there is a waiter. You tell the waiter what you want. The waiter goes to the kitchen, gets the food, and brings it back to you. That waiter is the API. You are the client. The kitchen is the server. And the API is the bridge between them. API stands for Application Programming Interface. Let us break that down. Application. Any software or app. Programming. It works through code. Interface. It is a defined way to communicate. So an API is simply a defined way for two applications to talk to each other. You do not need to know how the other app is built. You do not need to see its code. You just follow the rules of the API and communicate. Let me give you real examples you already use. When you check the weather on your phone, your weather app calls a weather API to fetch that data. When you book a flight on Make My Trip, it calls APIs of multiple airlines to get you the prices. When you pay on any website using UPI, it is calling a payment gateway API like Razorpay or PayU. When you see login with Google, that is Google's OAuth API. APIs are literally everywhere. Every app you use is talking to multiple APIs in the background. Now let us understand what actually happens when an API call is made. There are 4 things involved: a client, a request, a server, and a response. Step 1. The client sends a request. This request has a URL, a method, and sometimes some data. Step 2. The request travels over the internet to the server. Step 3. The server processes the request. It might check a database, run some logic, or call another service. Step 4. The server sends back a response. This response has a status code and the actual data. That is it. That is one complete API call. Look at the example on the screen. Get https://api.weather.com/v1/city?name $Hyderabad. The server responds with the city name, temperature, and condition in JSON format. APIs usually work over something called HTTP. And HTTP has different methods, also called verbs. Get. You are asking for data, like give me the list of products. Post. You are sending new data, like create a new user. Put. You are updating existing data, like update my profile. Delete. You are removing data, like delete this post. These 4 methods cover almost everything you will ever do with an API. The most common type of API you will hear about is a REST API. REST stands for Representational State Transfer. Do not worry about the full form. What matters is how it works. In REST, every resource has a URL. A resource can be a user, a product, an order, anything. For example, /users gives you all users. /users /1 gives you user with ID 1. Post/users creates a new user. Delete /users /1/orders deletes all orders of that user. REST is simple widely used, and the foundation of most modern web applications. Now, how does the data actually look when APIs talk to each other? Most modern APIs use a format called JSON. JSON stands for JavaScript Object Notation, but every language can read it. Python, Java, Go, everyone. A JSON response looks like this: curly braces, key colon value pairs. For example, user ID is 1, name is Ravi, email is ravi@gmail.com, ispro is true, and skills is an array with Python and Node.js. This is clean, readable, and easy for both humans and machines to understand. When an API responds, it also sends a status code. This tells you if the request was successful or not. 200 means, okay, everything worked. 201 means created. A new resource was successfully created. 400 means bad request. You sent something wrong. 401 means unauthorized. You need to log in first. 4. 104 means not found. That resource does not exist. 500 means internal server error. Something broke on the server side. These status codes are like the language of APIs. Every developer must know them. Now, not every API is open for everyone to use freely. Most APIs require authentication. The most common way is an API key. An API key is like a password that identifies who you are. You include it in your request, and the server knows it is you. For example, if you use the OpenAI API or the Google Maps API, you need an API key. Without it, the server will reject your request with a 401 or 403 status. Look at the example on screen. You pass the key in the header as authorization bearer, followed by your key. API keys protect the API from misuse and also help track usage and control rate limits. One last thing before we wrap up. You might have heard the word SDK, Software Development Kit. An API is the interface, the set of rules for communication. It is language agnostic. You write all the code yourself. An SDK is a toolkit. It contains the API plus helper functions, libraries, and documentation to make it easier to use. It is language specific and faster to build with. Think of it this way. The API is the road. The SDK is the car plus GPS plus map. Everything you need to drive on that road easily. Let us quickly recap what we learned today. 1. API is a bridge between two applications. 2. REST is the most common API style. 3. HTTP methods are GET, POST, PUT, and DELETE. 4. Data is usually exchanged in JSON format. 5. Status codes tell you what happened. Success, error, not found. 6. API keys protect access to private APIs. That is what an API is. Explained simply. If this video helped you, share it with one friend who is learning backend development. And subscribe to the channel for more videos like this. See you in the next one.